change, and don't be afraid. It's completely dynamical. And I'm sure that you will like very much.
Application of information. Go ahead.
Hello, good afternoon. I'm Marcelo Finger. I'm not a philosopher, but I have to deal with ethics in my everyday work. I am a logician. I've always been a logician, but then something happened. I don't know if you've heard about it. It's called the pandemic. And some people just stayed at home and decided to write the 11 papers they always wanted to write. But I didn't do that. I was too worried. So today I'll be an introduction about how I ended up really working with big data. Then I'll try to describe, basically I'll be telling stories, how artificial neural networks and big data co-evolved. Then I would say, well, I have to deal with ethics because of this co-evolution and having to deal with that. So I'll talk about bottom-up and top-down ethics. We'll deal only with bottom-up ethics, which is what another way to say about ethics in people on the front lines. And the front line will be people in the front line. In this case, means programmers mostly, but the data collectors and people involved in big data activities. And then my solution for the problems is ethical education. I'll give you lots of problems to think about. I won't solve them. I just have to deal with these problems. But academically, maybe you have ideas. So part one is the emergence of ethics in AI. That's the today's talk. Tomorrow I'll talk about logic and ethics. Today there will be no logic. So introduction about me and some of my projects. I'm a logician, a professor of computer science. I've been involved in natural language processing since forever. Since I finished my PhD, the first project was on natural language processing with logic, with substructural logics and all these kind of ways to deal with the language and logic, formalizing Montague semantics, etc. Blah blah blah. I'm not going into that, but I already had some acquaintance with natural language processing and techniques, learning techniques, etc. My students, I had some students dealing with that, and they were kind of mesmerized by the power of what was then the beginning of deep learning, and they taught me about neural networks. And from a total skeptic, I became I started to understand what was going on, and I became a practitioner. And then came the pandemic, okay? Heard of the pandemic, okay? So everyone was locked at home. I was teaching from day one. I think I was the first guy to teach remotely in our university, because on the day before the pandemic was decreed that no one goes to classes, okay? We had the 50-year celebration of my department, of my institute, sorry, of my Institute of Mathematics and Statistics, and all the old guard was coming, okay? And I had canceled the class that day. I was the head of the department at the time, said, don't come. Since day one, they knew I wasn't coming. And then there was all this, the university is going to close. No, it's going to close. Wow. When we're coming back? Will it be 2 weeks or three weeks? Is it going to last 1 month? That was the beginning of the pandemic. No one knew anything. And then, because of all of the old guard was coming, the event was cancelled. We didn't want the old people to come and get infected. We didn't know about the infection very well. We heard something about it. and it was cancelled on the previous day. And then I said, oh, remember that class that I canceled? Let's try and do it remotely. I had never done a remote class before, and I started teaching remotely. Okay, and then teaching remotely. After 2 weeks, everyone locked at home. This anguish, and I was teaching artificial intelligence, an artificial intelligence course, and I was discussing to my students what we in artificial intelligence can do to help people on the front lines of the pandemic. Can we do something about it? And I had the idea of maybe we should use their voices to measure if they have been infected. I had this idea of maybe the voice can give a hint on COVID. And a student heard, a student that works with helping this doctor. I don't know if you've heard about her. She was the first to sequence the Brazilian virus and all the strands of the Brazilian virus. She's Esther Sabino. And she heard the student that works for her told her about this crazy professor that wanted to do something about the epidemic, and she liked the idea, and we got in contact. And she said, "Well, don't do that. Don't do frontline people. We are having terrible problems in the triage, selecting people who should go to hospital, who should stay at home. Don't work with COVID. Work with the main symptom that takes you to hospital, which is respiratory insufficiency." Okay, and that's the SPIRA project. This one is, we started a project I have here in my cell phone. Collect your voice, and it will process through a neural network and tell you if you have or if you don't have not COVID but respiratory insufficiency. So you should go to hospital or stay at home. That was the basic question. At the time there was no vaccine, so you shouldn't go to hospital unless you need to. So this was the project, and I was very nervous. I had to put together a group, totally multidisciplinary. We had doctors, we had linguists, speech therapists, computer scientists, one musician, that was also a computer scientist. All over the world, there was a student who went to spend the pandemic with his family. He was in London. We had people in other states in Brazil, big mess. Okay, and I had to coordinate all them. I had nightmares that I would make a neural network and it would give me the result of 52%, which is just about tossing the coin. I don't know 52%, but that was my nightmare. Okay, when I had the first results that we were reaching the top 70s, I was relieved, but that wasn't the end of the story. Why? Because, I had never collected any data in my life. I had no idea. I was totally crazy. Okay, now I know I was totally crazy. Okay, cut. 2 years later, we went to present our results, some of our results in the Brazilian. It was an international conference in Brazil on speech therapy, and they said, "What? You went to the hospital to collect data during the pandemic? You crazy bunch of people!" They almost shouted at us, but they are ignorant because that was the best time in the world to collect data. You could get into the ward. There was COVID wards, full of people, everyone sick, beautiful. So just keep on collecting voice. No one talked to them. When we approached, "Could you donate the voice?" "Yes, of course. Do you know what the football match last week was?" They started to talk to us. There was kind of anguish, and suddenly there was a human contact so we could easily collect that. And then I didn't. oh, we had a terrible problem. There were no doctors and no nurses because they were all overwhelmed with dealing with the pandemic. So what do? We ask another doctor. Said, Anna, what should I do? He said, don't worry, ask my, what an academic does when he has a problem and doesn't know how to solve it. He asks his students to do it. So she had students that wanted, they weren't really doctors, they were fourth year students. So they wanted to learn how to go in an infectious disease ward. And they were the ones that collected the voice for us in the COVID ward of São Paulo University Hospital. And then I heard the first recordings, and I mean, I was shocked because a COVID ward is a hell. It's a noise generator, anything. You can have everything. You had the television on, nurses gossiping, people coughing, people crying, people talking, wheels turning, squeaking, all sorts of noise. I said, this is gonna be crazy. Why crazy? Because I knew I was dealing with neural networks, and all this noise is bias. And I was comparing with the data with people that stayed at home. They could donate their voice. We just went to the social networks, donate your voice. And we got 11,000 donations. That's a huge number. 5,000 of them I had to throw away, but that's something else. That's thanks to Facebook that when you click in a link in Facebook, it opens its own browser inside the browser, and that browser doesn't allow you to record voice. So I only found out when it was too late. Anyway, just for you to think that it's easy to do that. There's nothing close to easy, anything here. So I had this problem of people at home, no noise, people in the wards, full of noise, or different noise at home, maybe. So what do I do? I had two options. I could filter the noise, but that was suicide. But do you know in what part of the voice is the information about respiratory insufficiency? I didn't. So if I filter, I may be throwing out the children, the baby with the water bath. Don't do that. And then I decided to do something else. Because we are kind of third world, very improvised thing, I had the number of every one of the collectors. I sent them a WhatsApp and told them, please, whenever you get to the ward to collect, in the beginning of the session, stay there, send me a recording of the ambience noise, 30 seconds, and then you go and collect the voice. And that was our salvation, because I was inserting noise in every sample we had. There is a guy in my group who is a musician. He's a conductor and orchestrator. He said, "What? You're gonna reduce the noise signal ratio? Never seen that in my life." I said, "Sit down, you're gonna see." That was what made because we showed that when you start inserting noise we had to insert noise. We started inserting noise in the people outside the ward, and then we started inserting noise in everyone. Why? Because when you insert the noise, you insert discontinuities, and the machine learning can detect that. So I had to make everything bad, so that it won't pay attention to the noise, and it will focus on the voice of the people. The noise is everywhere, so it's not the salient part. And that worked very well. Okay, we reached when we first published our results, it was 91% accuracy. And then I got a postdoc and I said, "Oh, I've heard about this model. it's the same about the people using GPT. Let's use it here. And we got 96.5% of accuracy in recognizing respiratory insufficiency in COVID patients. Okay, good. We showed that there is some light. We can use a cell phone to detect. Or yes, please.
Sorry, the result was 96% of capacity of discriminating when you give lots of people who have COVID, or do you
Everyone. I get a population. We normalize, and we did lots of things. We normalized. Say we had 100 tests. We had lots of have 400 people training with COVID, 400 without COVID. More or less the same age, more or less the same sex, balanced, and we had 100 to test. Okay, of these, I got right 96.5%. Okay, that was shocking. I never allowed myself to dream about such a number. Imagine getting it. So this is one thing. So I'm dealing with big data, or what you call big data, because for me, I have 400 patients. It's very little. It's not enough. So I don't know who deals with big data. There's always someone else dealing with big data, because I don't deal with big data. But this second model, we used 600 hours of interviews in Portuguese, in Brazilian Portuguese, to train a model to get, and then we refined that for a respiratory insufficiency detection. So this was a kind of big data, okay? Why 600 hours? Because that's all we had at the time that was available. I didn't have to ask lawyers about it. Oh, by the way, every time I start a project now, I have to deal with lawyers. And the lawyers study my work. I am a researcher and a guinea pig for the lawyers. They have published the work, I can show you. Then, in something else, in this center of artificial intelligence is something that we got during the pandemic. We made a bid, we won, and I was responsible for the natural language processing, and we are building the largest corpus of Brazilian Portuguese texts. So, I think on the March 8th is Women's Day. Every year we plan to release a new a new release of the corpus on Women's Day. So the first one was last year, and we have what, 600 million, and this year we get 1 billion tokens of Brazilian Portuguese text, free. You can download it. So very easy. It's called the Carolina corpus. Carolina is in honor of Carolina Michaelis de Medeiros. She's German. She was the first woman professor in linguistics in Portugal. So we're not regionalists. We put the name of our corpus in homage of a woman, a German Portuguese woman. Okay. And then, well, I keep saying, I don't detect COVID. I detect respiratory insufficiency. I don't deal with coughs. Everyone was collecting coughs. We never collected cough. Okay, we collect language. There is a sentence, a large sentence designed by linguists with polysyllables, with breaks where you don't know where to put the break in beforehand. This was designed for the collection. And then we went to a competition on COVID by cough, and we won. Let's say the first COVID detection by audio analysis competition. Why? There was a category of speech, but it was too bad. It was lots of noise, like COVID words are the same all over the world, but I didn't have the word noise to insert to compare. So, and it was in many languages. I don't know, at least 6. But cough was fine, And why we won? Because we were used to noisy data. That was noisy data. We knew how to deal with noisy data. We were a little bit ahead of our competitors, and we got the first place. And we also applied the same ideas, the same machinery for sentiment analysis via audio in Portuguese. We got also the first place, and that was very sad winning, because we had our beautiful algorithm trained with 600 hours of Brazilian Portuguese, and then we applied that, it was horrible. And then we had to backtrack and try weaker models because we didn't have enough data. So how do you know that you don't have enough data? What calculus do you do? I don't do calculus. I construct a system and measure it. If it's too bad, I try something weaker, okay? So there is trial and error here. So we won it even though our model didn't win. And I have to be involved with ethics all the time, okay? Suppose you want to, when I had the first result, 91% accuracy in detecting respiratory insufficiency, the group said, whoa, aren't we going to put it on the internet for everyone to use? And I said, no way, no. Because I had trained with respiratory insufficiency with COVID. And people would be doing that without COVID and with all sorts of things. I didn't know if you can have respiratory insufficiency with many causes. Oh, say influenza, H1N1, H3N2, all the H's, there are 5 H's and 9 N's. They can all cause lung problems. You can have a heart condition that makes you respiratory insufficiency. There may be blocking problems, DPOC or how is it called in English, right? It's a new name for emphysema, or whatever it is. There are many lung conditions that can bring you to hospital. There are sleeping problems that can make you with respiratory insufficiency. There are many causes. Does my system work on those people? And I didn't know. I didn't have a clinical test. I didn't have doctors using it in triage, to select patients and say, oh, it works well or it doesn't work well. So I didn't put it on the internet. I had to take a decision. And it's a very serious decision because other people in my university and other universities, they put their solutions to the problems on the internet or made it available. There was once, before the pandemic, there was a pill that was supposed to solve some problem. It was still under study and it was free, and it was a terrible problem. So I decided not to. So I have to work with ethics all the time. Should I free? What should I do with the patients? I have to go through an ethics committee. They have to, normally they had to sign a term. It's a term of TCLE. The consentment, free and clarified consentment term. It's part of the law. We got an exemption that this term doesn't have, was the pandemic, everything was contaminated. So we got to record, the first thing record is that they say, I agree. So they agree with the terms that's on the screen. And this was used as a way around the problem. How to deal with the pandemic was our idea. And the lawyers saw it, oh, very good. And they wrote a paper about it. Anyway, so involved with big data. So for me, the goal of this talk here is I deal with ethical problems from the point of view of machine learning and big data practitioners, people that developing systems all the time, collecting data, writing programs, analyzing data, putting on the internet, bringing up sites, bringing down sites, whatever. Everyone involved. I want the ethics for the front line. Okay, that's what I'm interested in. Okay, and then, but the whole area is so full of hype. Hype is it's kind of a plague. Everyone talking about. No one knows what they're talking about. That's usually the case. So why all this hype now? What's happening? And the hype, which in Portuguese has a much better name, is the oba oba. It's perfect. It has been present in artificial intelligence. When I write IA, I mean AI, because I wrote in Portuguese the slides initially. So the ethics has been present in AI since the beginning, and in my opinion, the area, the whole, it's a new concept of not a person being addicted, but the whole field is addicted to hype. Okay, and it's AI is hype driven. Well, if you don't have hype, people say, "Oh, something's wrong." You know what they call it? We are in a winter. Our field is in a winter. Why? Because there's no hype enough. People are not giving enough interviews on TV, etc. So, and there has been several AI winters. I don't know how you count them, but since 1956, and hype. People feel that the area has been extinct. It's never the case. Okay. The other thing they will ask, oh, what's the fashionable now? Logic, probabilities, or connectionist neural network, whatever. Well, the three have always existed, well before 1956, but always existed. And what's happening now? Well, now we're having, sorry. We're having big expectations. Well, I'm shocked with the results I've been seeing recently with AI. Even my results have shocked me. But soon people start growing. There is a growth of expectation, and they will then reality won't match. Well, I want the ChatGPT to bring me good answers and well written. Well, they will be well written, but horrible answers for the time being. So this brings down the hype, and the hype goes down on the area and gets into a winter. I don't have patience for that. When you take the hype out, maybe what's left is science, maybe. Okay, so now I'll give you a brief history of the area, of the field of deep neural networks and big data and whatnot. Well, in the beginning, well, the area of cybernetics started with a paper by Marcelo and Peirce in 1943. The word was coined there. And the similarity between the brain and using that as a model for developing artificial neural networks started there as well. So very important paper, beginning of the area. And then in 48, Shannon brought his view, which has been implemented in the world, his way of transmitting information. And then Turing proposed his test in 1950, which is exactly what ChatGPT does. He fools everyone. Passed Turing test. He's designed for that. Anyway, and the hype started. In 1956, there was a conference which was named Artificial Intelligence, and the area of artificial intelligence has a birth date. Okay, it was the date of that conference in Dartmouth, and there was a lot of excitement and hype with the first. The computer was just starting to reach academia, and people were playing with them. Oh, this is electronic brains, whatever they called it, was 16K of memory. Wonderful. No operating system, no. So there was a lot of hype in the beginning, and immediately after that, the Frank Rosenblatt, he designed a perceptron. He was in Cornell, that's the Cornell C. Oops. I know that because I've been there. That's the Sea of Cornell, and he was trying to recognize images already with his perceptrons. And there was interviews and coverage in the New York Times, a lot of hype. Okay, but it failed miserably. And then, 10 years later or so, first there was I don't know if you've heard about that, but there was a Cold War. So the first thing they tried to do with the artificial intelligence was a translation between Russian and English, and the problem was hard, and the results were horrible. Horrible means no money. That's what means horrible. Okay, and so in 1968 they tried to do this Russian English translation. It was a flop, and then Minsky and Papert published this little book about perceptrons, in which they proved that perceptrons couldn't do certain things. Well, cannot explain the exclusive OR, blah blah, but that was just one layer. Okay, and no one read that. They said, "Oh, this artificial neural networks is rubbish." But the air was kind of frozen for 10 years, until someone said, "Oh, but if you plug 2 layers, then you can express exclusive OR." Yes. So that was the first death of the connectionism, which death means no money. Okay, no hype, no money for this type of research. But then there was this big project. Oh, there was a very small project in the beginning between France, Kommerauer, and one American that was a professor in Edinburgh called Bob Kowalski. And they invented the language Prolog, and there was a big excitement on theory proving. And there was this big, in my time, doing artificial intelligence meant, oh, you are European, you program in Prolog. If you are American, you program in Lisp. That was what was the right language for artificial intelligence. Total nonsense. These 2 languages are not very much used today, and AI is booming. So that was total nonsense, but that was the thing. The notion of an expert system was born at that time, then it died, and it came back again. And the idea of knowledge modeling, of an area of an activity like let's model knowledge, started around that time. And then Japan had too much money and didn't know what to do. It was before Japan went into this never-ending stagnation in its growth, but so the 5th generation project funded Prolog, funded all this, and didn't bring exactly the results they were expecting. So it was another deception. Okay, so this big explosion followed by deception, and the end of the 5th generation project. There was an article by Bob Kowalski in one, I think it was IEEE, one of the main magazines or communications of the ASM, I don't remember, kind of saying, oh, we didn't get what we wanted, but we learned a lot. And in the middle of the 80s, there was a rebirth of neural networks when Hinton, actually he reinvented or he put back together the idea of backpropagation, and he gave the name backpropagation to the algorithm, which is the algorithm that's used to train this very simple neural network here. This is very simple for today's size. And well, it's backpropagation because you put the data here and then you calculate some derivatives and you propagate back. So that's the idea. But at that time, there wasn't enough machine power or data to feed that. So the big neural networks had 23 neurons at the time. That's the number of neuron theses I attended a little bit later than that. People were using it for engineering, vibration, measuring 23 neurons. That's pathetic. You're never gonna You're not going to recognize any patterns with that number of neurons. It's too small. Now we know that. So backward aggregation needs much more money, much more power and data that was available. So it was a big boom and then a quick bust. Okay, when I did my PhD in the late 80s, beginning of 90s, everyone knew that neural networks didn't work. It was kind of knowledge where things overfit very easily. It doesn't work. So let's do something that works. Let's do logic. Okay? And then, so this started a new AI winter with the end of the Japanese 5th generation project. After spending 50 billion yens and whatnot, and the expectations about artificial intelligence were frustrated. But wait, there was artificial intelligence died for the rest of the world. In academia, it was very active. That was about that time that Judah Pearl's project on Bayesian networks was getting into 4th gear very fast, acceleration very fast. So there was work in logic, there was work in probabilities, and there were some crazy people still doing neural networks. Can you believe it? Okay, fine. But that was a AI inter at the doors of a revolution. And two things happened. The internet started becoming popularized around that time, and computers started getting into people's house. Worse, they started getting into children's play, becoming children's play. And the kids were playing games, firing shots, and it was awful. It was doing, and then refresh, and then refresh, and then refresh. You didn't see that. It was painful. Then someone had the idea, wow, we can do an acceleration. So you say shoot from here to there, let the screen calculate the trajectory of the shoot, and then you're gonna see something really shooting. And started with adding video cards, and that's very important for a neural network. Yeah, because these neural cards were very stupid things that could do lots of sums and multiplications very fast, in parallel, many of them, okay? So people were playing video games, and that helped neural networks a few years on. So then AI exploded. Why? Because there was an evolution in hardware and technology. The GPUs that were used in the machine to accelerate the video, now we use them to train the neural networks. They are fundamental. Without them, it's very slow. We had very powerful video cards used to train the machine. Those cards are not connected in any video. If you connect them, you know that rice race. You've seen that OTVs, when you get static, that's what you're going to see, but no one does. If you use this video machine, these video cards to do computation very fast in parallel, and then the internet now started providing big data, really big data. Started, wow, terabytes of data. It was shocking, terabytes. Whoever thought of terabytes? First time I heard about 150 megabyte disk, I said, oh, who needs all that? I was a second-year student. Anyway, and then the neural networks started evolving. That's already 2014. This is the circuitry inside an LLTM neural network. There is all the circuitry basically because it has memory. An LSTM machine is a machine that gets the C connects to the CT-1 connects to the CT. It's actually a single cell, but it circles, and it can decide if it's gonna, from the input data, can decide if am I gonna learn from this data, or I prefer to to maintain the memory I have of the past data. Okay, this is one solution for the vanishing gradients problem. But anyway, not gonna talk to you about that. Oh, by the way, if you want to know more about this, I am releasing a course just after Carnival on Coursera, telling you about all that. During the ad time, I'll do the marketing. But I'm releasing a course on neural processing of natural language in Portuguese on the internet. So this is a recurrent neural network started working then, and then things started getting more interesting because we had an idea about translation, an advance in translation. We had one of these recurrent neural networks. They would process a sentence and get S here is the code. It's actually a vector that encodes the sentence. I won't say meaning, because there is no meaning anywhere here, but encodes the format or whatever it is from the sentence S, and then this sentence can be used to generate here. First, the low is the beginning of the sentence, a sentence in another language. So we have this sequence-to-sequence translation process. Started with these recurrent neural networks, and this is an idea that caught very much, stayed with the area. Well, 2014 is still prehistory, okay, still old. But anyway, this is something that made translation improve a lot. The first versions of Google Translate used the first versions used in 2011 used statistical alignment, and then they started playing with neural networks, and this kind of thing was proposed by the Google group, and it was a very interesting idea. So you take one sentence, encode it, and use the encoding to generate recursively, because you generate the first word, and then you plug it back with the coding, and the first word, you generate the second, and then you plug it back the code, the first two words, you generate the third, and this is called an auto-regressive way of generating sentences. That's precisely the way ChatGPT does it until today, with a deeper network. That's it. Okay, this is a sequence-to-sequence model. This is big data, okay? Started here. Deep learning started here. And then people said, well, why don't you, the naming is horrible, okay? They said, well, why don't you pay attention to what you're doing? That's bullshit. What you're doing, you calculate a correlation between the output and the input in that order. And this will increase your chances of getting right, especially when there is a change of order between English and German, or between Portuguese and Japanese, or whatever. So this attention mechanism, which is nothing but correlation between output and input, started getting things, better translations. Measuring the quality of a translation is hard. I mean, there are measurements that everyone uses, they are bullshit. They measure 4 words, context of 4 words. It's not a good way to measure quality of a translation, but you can see that, well, suppose you are trying to translate something from one language to the other. You used to put, say, in Portuguese and get it in English. You had to work a lot in English. Now you work every time less and less. So, no questions, everyone knows all that. And around that time, something that made a big impulse, there were public libraries for using these things. All these neural networks, how you train them, etc. They have been packaged by Google in TensorFlow and by Facebook in PyTorch, and everyone uses that until today. That was a big, wow, everything is ready. It stopped being programming. It started being Lego. You just put things together and bring me the data. At least the people that don't know about whole process of biases, and you have to record the noise on. They think that's easy, but it looks like Lego today. It's today programming neural networks is very simple. I mean, you don't write these kilometric programs. The neural network is normally 5 or 6 lines. Really, data processing, the pre-processing, etc., takes much more effort today. So there was an explosion in neural model availability. A model, what's a model? A model is a trained neural network in which the weights have been assigned. That's a model. So when you train model, you execute the model, blah, blah. So in this context, the word model means a neural model in which you have all the weights there. Okay, I'm finishing this, but just for you. And then we reached the, not maturity, okay? We left the infancy of neural networks with this kind of network. This is called a transformer network, and it was a brilliant idea. It's crazy what goes on, but at the same time, it has a lot of things going on, and it's very simple, okay? So there is no recurrence anymore. In the good old times, when you had a neural network, there was, what's the advantage of neural networks compared to logic? Okay, let's say, what's the advantage of a neural network compared to logic? Logic is very bad for context. And normally, even when you do probabilities, you take the current word, the next word, and the previous word, and that's already power of 3 because you have to multiply everything. And the complexity of your systems goes with the window in which you're trying to compute. Neural networks have evolved toward being more and more sensitive towards the context. So in the beginning, processing was actually looking in a window of 3 to 5 words. That's more or less what we did, centimeter, and could get good results sometimes. 90-something% correctness in some problems, but it was very limited. And then, yes?
Just to get into this, if you...
I haven't explained anything here yet.
Oh, sorry.
But, so then there were models like Word2Vec and etc. that started improving the breadth and being more and more sensitive to the context, being able to detect things. And then when we get recurrent neural networks with, you could process whole sentences. You could translate the whole sentence at once, not just the 2, 3 words, but the whole sentence. Here we get 512 words, okay? For someone that was used to 2 or 3 or 5, a window of size 3 or 5, 512 is infinity almost, but it isn't. We still can't know that the murder in chapter 1 is the milkman that appears only in chapter 7. There's no way to correlate that. And correlation is all it does. This is a correlation machine. It's an encoder and a decoder. The same way, it's autoregressive generation of the encoder and the decoder. This was proposed with no recurrence in 2017. And this is kind of the infancy is left behind. Okay? And it took 1 year for people to learn how to train this thing. There was this thing for, and some people said, oh, it's too much. It's very big, too much. Let's slice it. I'm gonna train just the encoder. I'm gonna get all big data from the internet and do a language model of English. Okay, there is a selection of texts, some curation. Well, throw away texts that are not from English, can do that with 3%. Today they can do it with 1%, but at the time it was 3% error. Train that, get the model. And then you can refine for different problems. We can classify the sentence, we can label the words in the sentence, many things just from this first half. This is called BERT. Bidirectional, blah, 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 transformers. Okay? So we learn how to train this huge machine. And then, okay, you're learning the encoder. Why don't you do the same thing for decoder? So you take the second half of this architecture and build a model with lots of text that knows how to generate text. And that's GPT. That's what they do. It's this half of this architecture. It's actually a translation problem because the first half, instead of encoding the whole a whole sentence, the prompt becomes encoded, fed here. Well, never mind. The prompt goes here, then the sentence you're training goes here, or the sentence you're generation after training goes here, and here you generate a probability on the word of the whole vocabulary. So you generated the text. Self-recursively. That's what GPT does. This is GPT till today. The problem is, here I have n times, maybe you cannot read, but it's called n times this module. And for BERT, there is a light BERT, which is a BERT small, which is n equals 9, and large BERT is n equals 12. In GPT, I think it's 24 n here, GPT-2 maybe. There was GPT-1, GPT-2, GPT-3, and then ChatGPT. In GPT-3, the number of parameters you have to learn here, the way this is stacked on top of the other, it's on the order of billions of parameters. And I'm not exaggerating, it's the 1.75 billion parameters. So it's very huge work, lots of texts. I don't know how many GPUs they use. I know they published the number. They like to show their muscles, but I've forgotten that. Okay, so this is really big data and big money. Microsoft has invested $3 billion in developing OpenAI. Why? In developing GPT and ChatGPT. Why? Because for years, Microsoft was not in the lead of anything. Microsoft wasn't the company. It was a company that had the Windows system and spreadsheet, Word, and all that thing. But they never had any big product technological after that. There was a fight of the browsers in the 90s. But yes, browser now is part of the operating system. And Firefox has always been better than any Microsoft product. So this make machine learning. So Microsoft decided, I can see there's something going on. GPT is very big, so they put a lot of money. And I think part of this money, they curate the data. They pay a lot of people to select and classify the data there. Because when you write, please write this in verses, do this in the style of the 80s. Someone must have told them what's the style of the 80s. People. So they have paid, a lot of money have been gone into curating the data that's training GPT and ChatGPT. So now this method of training is by self-supervision. What do you mean by self? How is the model trained? You put a sentence or whatever you can fit in 512 words, and you mask or delete 15% of the data and make it guess what words were deleted. So after doing that zillions of times, if Daniele allowed me to use this measurement that he uses a lot, zillions of times, you start the machine, the model starts predicting what comes after what. Well, that's how you build a language model in English, in Portuguese, in other languages. By masking and making it guess, and it will make a wrong guess, and then will be perfected and more and more, lots and lots of data, several epochs, I don't know how many, until it learns. And then it has a data model, and then it can be refined for certain tasks. And that's where we are now, okay? I'm not gonna bother you. So this is BERT with 12 layers. So 12 layers, lots of drawings that I've stolen from the internet. I'm not gonna explain them. Do my course. Okay. Now ethics. Yes, please. 1, 2.
Question number 2. We'll try another subject. Would you say that the model garbage in, garbage out remains true and will remain true, or these neural networks are able to?
No, you have to. It's not garbage. I mean, I said you have to curate the data, pay billions of dollars for people, hiring people to select and say, oh, this is the style of the 80s. This is a rhyme. This is something else. Give a lot of information. So that people say, well, what will the jobs of the future be? Data curator is certainly one. Okay, it's not the future, it's now. My people do that. When I developed my the corpus, Carolina corpus, we do data curation a lot. Okay, so this is the job of the future in the present. So no garbage. If you put garbage in, get garbage out. To train this, you need data is hard, and good quality data is hard and expensive. So you think it's easy to get information about people with respiratory insufficiency? Try and find it on the internet. There is none, absolutely none. You need some students going during a pandemic collecting. I've tried to do that collection after the pandemic. Well, I'm calling it this half second. It's impossible. I'll tell you about it later. But
humans to collect and curate.
Yeah, all the time. We heard every single recording to see if there was, because maybe some people record hello instead of saying the sentence we want. We have to curate all that. Yes, please.
How far we are, because
How far from what?
from automatic curating, the database,
How far we are from?
that of creating the database automatically.
No, that curation means human.
Okay.
Okay, what happens? When people train BERT, this model here, today they select text in English. The state of the art makes a mistake of 1%. But 1% of a zillion of terabytes, I don't know how many petabytes, okay, is 1% of that is already a lot. So that's why people claim these models, they transfer to other language very easily, because the other languages are already in. They haven't been eliminated totally by mistake, by failure of the automated selections. There is no human curation. You have all the languages. There is Italian, there is German, and Chinese, whatever in here. Yes?
Mary, thank you very much. I was looking forward for all of this. It's a technical question, but I'm from philosophy.
Okay.
I would like to know a little bit more about attention and the difference between attention and self-attention. I don't know if it's I don't know if I will.
No, I can explain. That's easy. Okay, attention is correlation. It was developed. You correlate the output with the input. Okay. Today we have 3 types of correlation. Self-correlation, in which you correlate the input with the input, the output with the output, and the output with the input. So self-attention is this input with input, output with output, mask output with output. That's a technical thing. But self-attention is just you correlate the input sentence with itself, not with its translation. Okay? And that's all there is. Don't think too deep. It's not deep. Well, the models are deep, but it's very simple. And you say, oh, why you have several heads? There are several heads here. I didn't say that, but this is. It has to do with how you instantiate. You let parts of the system learn parts of the language, and then you combine them together. It's very smart. I mean, it was made by trial and error, lots of experiments. Most experiments go wrong, and the ones that survive, they are incorporated, as usual. Yes, please.
For writing formal mathematical proofs, since we have, I know that
There is no proof of anything here. No.
very hard problem, but since we have proof verifiers, we would have an automatic supervision. Do you think there is any hope that this large supply of supervision could
Be formalized? Yes. In 20 years, it will be totally formalized and obsolete. I mean, the practice goes well ahead of formalization comes afterwards. You're just trying to know what should be formalized. So the moral of all this is that what do you learn after all this process of training neural networks is that what's doing? Pattern recognition. That's all that's happening here. It's pattern recognition. It's comparing one thing with the other. And we learn by optimizing a function that doesn't have a maximum. It's a more or less optimal, suboptimal, or a good enough optimal. It's a good enough optimization. Okay, and it's good enough. Well, it's very good, actually. But what we learned after all these years, or since 2017, since this model has come, is that who could dream of the power of pattern recognition? It cannot capture causality. It's still limited. It doesn't relate something that I read 2 months ago with what now. It doesn't relate the polynomial manipulation I learned 40 years ago, and I can still remember today. It doesn't do that. The brain doesn't work anywhere similar to this. No way. I went to study that. Brains are embodied things. It's a very interesting thing, but it has nothing to do. It was an original metaphor that was applied, and it's capable to recognize patterns with a broad context, and it's very powerful, but it's not a brain. Yes?
Where does logic intervene here?
Here,
Yes.
tomorrow.
Yes. I have a similar question that is, from your point of view, logic has some future in AI? I mean, like
Yes.
explainable.
It won't die. You think logic will die? Everyone is discussing logic here. Come on.
But not that
It's just for
the diet.
universities.
I don't see it here. I mean, what
Yes.
you will tell tomorrow.
I have worked with logic and neural networks.
Formalizations came
Yeah.
later.
It has to do with the Lukashevich multivariate logic. Believe me.
Okay, my question is quite provocative because what you're saying is that it doesn't matter how the word works or whatever. It's just that you input this input and you maximize it against this metric.
With a lot of data and a lot of parameters.
So it seems like maybe language, philosophy, or like natural language, maybe just statistics. It seems to me that you're trying to like define this.
No, I said, who could imagine that pattern recognition could go that far? If you told me 10 years ago I finished my postdoc, I came back to Brazil and said, oh no, everything is going to be neural networks and they are going to dominate everything. Crazy. But no, you're not crazy. It's true. I couldn't imagine. So what we learned in scientific terms is the power of pattern recognition. It's not very well formalized. It's not very well understood even. Well, that we have hunches. We know biases and all these things. We try to eliminate or balance, and this has good results. But we don't really understand this with the formality. Yes?
So you said that this is not how the brain works, fair enough.
No, absolutely no.
But if this is a good pattern recognition system,
Yes.
assume that it can get better and better. At
Yes.
some point, it might find out exactly how the brain works. Because it's a better cognition system,
well-
the brain has a better functionality, then it can.
It can be useful, okay? One thing is being useful.
Yeah.
Other areas of computer science have left the brain behind. I mean, ages ago, and no one keeps comparing, oh, how much data I can handle in my brain and how much data I can put it in a database. The database wins by, wow, no one even discusses that, okay? Here, there is this, tendency of trying to compare with the human brains. I'm just saying, if you try to compare the human brain, you won't find any similarity at all.
But my point is, if that recognition of atoms happens,
It happens in the brain, yes.
yeah, I mean, if the.
But that's just a tiny,
if the-
weeny part
if
of
the-
it.
If the neural system there, the formal one, captures how the brain works, would we study that system to find out how the brain works? Or would.
Can you study the state of the state of the memory or the evolution of the state of the memory to understand an algorithm? You'll be looking at the circuits and all that. You're looking at the trees, you won't see the forest. There is one quick reason why this is not the brain. This is an open system. This works with a false metaphor of how the brain works. Okay, this is what give me the data I learn and then I go to the world. The brain doesn't work like that. The brain works in a closed loop. Okay, you initiate. I want to look at you. Okay, I want to see you. So my eyes go there, and then there is a saccade, a jump, and it compares them, and then it decides, oh, you're there. There is a reflex there. You have a ring here, there, and I see a static picture of you, but my eyes jumping because my brain is telling it to jump. So it's totally working in a closed loop, and that's not at all how these things work, at all. Okay, so don't be fooled by the name artificial neural network. There is nothing like a brain or even a neuron in it. Yes.
I have more of a comments than a question, just related to this question. I once saw a talk a couple years ago relating to actually formal modeling of artificial intelligence.
Yes.
And the presenters concluded that current technology is effectively impossible. You have your AI here, and another AI which has perfect answers to all everything that the other AI could not put.
Maybe we have to invent more mathematics that's more suitable to deal with that. It's possible, yes.
We call it an oracle.
Yeah.
Oracle AI, which has cipher knowledge.
Yeah, fine. Anyone, another question? Oh yes, maybe probably we need more mathematics, a different kind of mathematics, some developed concept to deal with them. But it works, it's crazy, right? In the beginning I was a skeptic, and then I saw it working. How I was converted to neural networks is when a student of mine took a model, took 3 models and applied for natural language inference, okay, took 3 models. There wasn't a Brazilian Portuguese model at the time. There was an English model, a Chinese model, and a multi-language model. And we had other models. And the Chinese model applied to Portuguese went much better than the previous one. The English was even better, and the multi-language was even better because the multi-language had 1/100th of Portuguese, more or less. So we take a different language model trained in Chinese and apply to Portuguese, and it works. Okay, come on, something's going on. Wait a minute. Okay, I cannot say, oh, not formal, not looking at that. No, I had to look at that. And we published a paper on that. Anyway, okay. Now ethics. When we deal with that, we are bound to have to face ethical questions. So the emergence of ethics in big data. So now you've seen big data. Wow, it works. Don't know why. I don't know either. I can try to explain what it's doing, but knowing, no, I don't. But people don't understand the quantum mechanics either. So first, so what happens? We have large systems and millions of decisions to construct a system. Like it's an everyday thing. How am I going to pay for the collectors? Where are the connectors are going to go? What happens if there is no internet there? Blah, 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 blah. And then suddenly there is an ethical question in the middle of all that. So we need to answer questions of many questions when you design a system. And one of them is ethical. You don't stop, oh, it's ethical, let's keep. No, you have to process it like the others. You have to solve all this problem, otherwise the system won't be built. Okay, so these decisions, they impact the amount of money you make. So Microsoft is not putting $3 billion just because they think it's nice. Okay? And impact people's lives. If I go on and release your data saying it's yours, when you are suffering for, say, respiratory insufficiency, I may be affecting your life. And the decisions impact work complexity. When you're deciding, so always the tendency is for people that are working in the front lines to choose what's, be easier, give me less work, I'll be able to finish soon and go back home and watch the series of the week, I don't know, fashionable. And my view is that the ethical problems, they happen much more between when you think of work complexity and how they impact people, forget to think about how they impact people, then the impact of money in people's life. This is the big management decision. This is the frontline decision, work complexity, how it impacts people. So this is just a hint of what makes the emergence of ethics in big data. And just look at this. There is nothing big data in this one. I mean, it's not a set of characteristics or decisions. They are not big data. It's not particular to big data. Any big system that affects people's lives can deal with that. So, and design of an aircraft or a car or a road system, this also has impact on people's lives. Are you going to make the complexity of building a road and not worry about people's safety? No. You should take that into consideration. So this the ethical decisions, they arise from conflicts between these decisions, these things that you want to take into consideration. So it's not at all restricted to big data. Yes.
Because this revolution in big data was, as far as I know, was really important in the work of the so-called mechanical Turk process, right? The people would be paid to respond if this is like captures, right?
Well, mechanical Turk is a way of getting data. Okay, you pay people and you give a bad name for that activity, for the data curation, data generation, data curation. So you paying people's brains to give you data.
Yeah.
Yes, but I have data collection that doesn't involve mechanical Turk. It involves students going there, collecting data, sending over the internet a voice. There is no mechanical Turk here. You need the person to be ill. We measure the amount of saturation of oxygen in their blood, and if the saturation is below 92%, we consider them having respiratory insufficiency. So,
But the question is, usually this training part is for perhaps the collection of data or the process of data, this initial process, this filtering of data that was so important in this revolution in the 2010s. It was like dependent
a little bit on this part that they used to call the multi-culture, which were people like getting paid really low.
Oh yes, there is exploitation, but oh yes, of course.
So you think there's
Old practices die hard. There was slave labor involved in that. People being paid very little for the brains. Yes. I think a company that OpenAI hired for doing something was accused of doing that. Yes, I mean, when one new method comes, it comes on top of what there exists. It doesn't come unavoided. So if there exists slave labor or slave-like labor, when the new technology comes, it comes with those practices as well. Okay, and so it's not because of big data, but because the practice was there. People have been doing that for a long time. So it's neither big data is neither blame or blameless in this case. They have to the same way that if you have you have a clothing factory, you have to worry about paying enough to your labor. The same thing here. It's the same problem because you're using their brains, both cases. Yes. So you see how many you have problems of eliminating jobs. It's a serious problem. Okay, because you're creating new jobs, but who said the person you are displacing can learn to do the new job? Probably not, never. So which ethics for big data? So when people discuss ethics, there is top-down ethics. Well, say the principle of ethics, the ideas from Aristotle's or Kant's categorical imperative, etc., which I won't touch. Okay, I have nothing against, but I don't deal with that. You may use that to justify your decisions, but what I'm really worried about is bottom-up ethics. Is the ethics that guide people on the front line, where they all these decisions for programming, you do that, and you do that, and then there are some decisions that people don't even realize they have a lot of impact in other people's lives. You are affecting the life of a community by a decision, and you may take the wrong decision just because otherwise it gives me a lot of work. Okay? So I'm worried about the ethics of machine learning and big data people, programmers, software engineers, interface designers, data collectors, data analysts, data preprocessor, whatever, data curators. You know, a few years ago, before the pandemic, there was an intelligence Microsoft put on, and it was in a week it was trained to be a fascist, racist Nazi. It's a well-known case. So there is no use for big principles here. I'm not worried about big principles when I have to deal with this fast decision. On the front line, people are focusing in their goals. And there are thousands day-to-day decisions. And there are never enough resources to derive from big. Deriving, deducing, inferring is very expensive. Even in propositional logic, it's NP complete. So there is no use for that here. It has to be quick. So I don't know if you've seen that this Thinking Fast and Slow by Daniel Kahneman. He's the father of the area of behavioral economics. He's a psychologist. He invented the area with Amos Tversky, but only he was the only one who got the Nobel Prize of economics, because the other one had the Amos Tversky was unpolite of dying before that. Yes, Vita?
Sorry?
You raised your hand?
No.
No?
No.
So,
I'm thinking.
when you think the brain has these two modes, thinking fast and thinking slow, I'm worried about the thinking fast. And the fast is not optimal, it does foolish things, but it's the one you use all the time. And the slow, well, it takes years to train. And one can infect the other, but I'm the bottom-up. Ethics is the bottom-up, is the ethical words that arise as a reflex. You must be quick to take an ethical decision. So you won't be deriving it from big principles, but you'll be deriving it from a habit. You have the habit of worrying about these things. You must be trained to worry about these things. You must be trained. Oh, should I include the zip code in when I'm training this machine? No. Okay, next. No, why not? You may be discriminating against the whole region just by adding. Because if you live in a poor region, and if you learn that there are bad people living there, and you are a good person living with that same zip code, you'll be discriminating against, because it learned the pattern that zip code is bad, and no matter how valuable you are, you can be, if you're being selected for something, if you add the zip code, you'll be discriminated against. So you must be trained to do this thinking quickly. Yes?
So you have to fail first, or
you have to learn from other people's fails. Yeah, you learn from failures. You put a hand, oh, it's hot. Okay, no, not putting the hand near the oven anymore. Yes, it's that kind of.
So there is no guided way to think about.
Yeah, there is guided way in education. You have to be, when you're developing the system, you must be trained to think about that. That's the end of my talk. That's the end of my talk. Yes, yes. So habits are studied by neuroscientists and psychologists, not usually by philosophers. But I'm worried about
Charles Peirce.
Except you are Charles Peirce.
Conceptualized yesterday, habits
Yeah, but
by Charles Peirce.
can you apply that to
would
here?
Be very good here.
Yeah. Yeah. Once you formalize this thing, but I'm worrying having this quick. Okay. So ethics viewed from the front line is avoiding math destruction. So you see where I'm going. So common decisions must be ethical decisions. Should I collect this piece of data? Will it cause me problems if people know I know this? So when I collect the data, I don't get the name or any number that can pinpoint the person. Of course, people can be recognized by the voice as they can be recognized by the image. So the voice takes a lot of effort. So when I collect people's data, I don't want to know who they are. I have no idea who donated voice to my project. And I will never know, and I'm glad about it. If you donated, thank you. But I don't know anyone. Oh, my grandmother also. I don't know. I don't have any proof. I cannot relate because I don't want to be possible to leak that information even against my will. So if I include this piece of data in the analysis, what kind of biases will introduce, like the zip code? Zip code is a famous one, but there may be many, many more. Will some group of be negatively affected? So if the system learns that this area is bad, people that are good but happen to live in that area, you must know that the system is capable of biasing against things, and you must try to avoid it as a reflex. Don't add zip code in data learning automatically, depending on what you're doing. Can I change ways to say, oh, don't go this area is bad? Will I be discriminating against the people that live there? It's a tough question. People are trying to do that. Should it be done? So this is the main book. This was prior to the big data thing. It was just pure math, Weapons of Math Destruction by Cathy O'Neill. It's a very nice book. I really recommend you read it. It's easy reading and it's shocking, absolutely shocking of the kind of discrimination data can do against people. The practices. So we live in the age of the algorithm, increasingly in the decisions that affect our lives, where we go to school, whether we get a loan, how much we pay for insurance are being made not by humans but by mathematical models. And if you have data that can be biased against some group of people, it's a big problem. Yes, please.
What are the metrics used to say a piece of data is biased or not? If there's so.
The bias is always in related to what you want to measure. So if you have a task of say recognizing an image, say I'll tell you about a famous experiment, wolves and dogs. Okay, wow, and the system worked very well, fantastic. Ooh. People couldn't detect the difference between dogs and wolves, but the machine learning was wonderful until someone noticed, well, the wolves are always in with the snow behind, and the dogs have a background of urban. So how do you prove that the system is biased by the background information, not by the image? They blurred all the images of wolves and dogs and just left the background there in place, okay? And then they measured, and the system had the same quality as before. So it kind of not proved, but was a strong evidence that the system wasn't looking even at the dogs and the wolves. It learned to look at the background. That was the easiest way to discriminate. That's why I said I had to put noise, or otherwise I would have a wonderful discriminant if the person was in the hospital or at home. That's not what I wanted to measure. Okay?
Thank you.
So we learn by the failures of others. Yes. Sorry, what's your name? Lucas. Yes. We learn by the failures of others, but we must learn. We must not ignore the failures of others. And this failure was repeated many times during the pandemic. AI was useless during the pandemic. Mostly, I've seen reviews of, I have to tell you this story, okay? Interval. I'm late, but anyway. I have to tell you this story. This AI was useless, and it was pathetically, people try to cut corners that cannot be cut. If you, people were trying to recognize COVID infection from X-ray images. Very hard, okay? And you know, there are hospitals that get the bad cases in other hospitals that they had every now and then a bad case of COVID. And they put all these images together to train the machine learning to recognize COVID in the lungs from X-rays. And you know, X-rays, normally you've seen X-rays, it comes written with people, left lung, right lung, the date, many things, and they didn't cut out that, they left all that. And it turned out the best indicator for COVID in the lung was the type of the font. It was the font of the hospital that had the bad cases. Okay, the system learned to recognize the font of that hospital. If you had something written on the X-ray with that font, it would say COVID. It's bias. You should design a system to avoid the bias. I've told you since the beginning, bias is the big problem. But they didn't do that. So the whole X-ray image recognition for COVID was dumped, was hopeless. Anyway, and that's not an ethical case, just a simple case. But I'm going back to the ethics now here. So she describes many cases in which data may discriminate against people. In theory, this should lead to greater fairness, but in practice, the opposite is true. Okay, having a machine deciding things for you lets the bias that you feed the system decide it for you. That's what's happening. It's all there, okay? So this is, I just copied, I adapted from the book jacket. So this is, the sentence is not mine, just read it. So there are many case studies. I don't have time. Maybe Friday we'll go through this. Okay, I'll tell you about all these problems, ethical problems. The case studies, famous, described in the literature. Even the London ambulances in 1990, a very famous case. And there are many. Can stay hours telling stories. Normally, I prefer to tell stories than to teach. But anyway, I think the stories teach much more. I don't believe in teaching. I believe in letting the students learn. I don't teach anything. I do what I like, and I like telling stories. So maybe Friday I'll tell you a few stories about this. All these cases. Okay. So ethical education. So preventing mass destruction. Education or training of people, okay, is the main tool to promote frontline ethics as a habit formation activity. That's my whole idea. That's the whole point. Okay, and we have to be trained to say, oh, this is a problem. Wait here. It's an ethical problem. The same way that I have to decide how much I'll pay. What happens if there is no internet? What happens if I have an ethical problem? I have to be quick to take this decision. Or I have, or the people in the front line have to. Okay? So not educating or training for ethics is a statement that it doesn't matter. I'm not teaching because I'm stating that I don't care about ethics. Okay, so, oh, I forgot to tell, no, you forgot you stating that you don't care about ethics. And when should it be done? It should be done in our computer science program, education and everything, all the time, in parallel. My natural language process, I talk about ethics in the first lecture, and I come back every now and then, and in the end, the last one is about ethics as well. So it's not, there is a right time. The right time is always in parallel. When you teach programming, software engineering, AI, machine learning, databases, whatever, theory. I think theorists should also worry about what they're theorizing about. So that's my point here. That's my experience with ethics. I have proposed a new project. I'm trying to help people stop smoking, and I am proposing a gamification of stopping smoking, because people, it's a hard activity. They try to stop smoking, but they have this compulsion. It's an addiction. So I decided to tell them, talk to me, and I'll show one number going down. The number is the exhaled carbon monoxide, which is used to detect, it's kind of tells if the person has been smoking. When you know I'm not a doctor, okay? So whatever I say, please forget. But there is a hemoglobin, and it connects with the oxygen and carbon dioxide, but the link is weak. The link with carbon monoxide is very strong. It has an exponential decay of a half-life of 4 hours. So when you smoke, you can detect that you have been smoking at least 2 days afterwards. And I'm proposing to detect if we can detect that from the voice. Maybe I'll fail, but I'll have a lot of data of smokers, and this will be to learn to detect it. And that's easy. That is described in the literature that there is a voice of smokers. Maybe we can gamify stopping smoking. The guy will speak, and they will see the number coming down. So when he has his craving, instead of going to find a cigarette, he will find, say a word, oh, the number is lower than 3 hours ago. Good. And it never be zero, because the body, the human body, produces carbon monoxide in its own naturally. So it can come down from 17 to 2 parts per million, but it will never be 0. If it's 0, it's a problem. It's dead. You're not working properly. And I have to talk to lawyers about this thing. And I have to talk about the many problems. So good that I'm friends with the lawyer and the lawyer studies me, so we have a good relationship. When I have to say, oh, I have to talk to my lawyers, I'm not in trouble. Not yet. Yeah. And teaching the workers is also a boss duty. That's my last slide. So it's a problem of education and it's a problem of the working space. So tomorrow, I'll be talking to you about big data and logic. Hopefully. Thank you. Lucas,
one problem is how to eliminate biases, right?
right. You never limit biases.
Yeah,
Just,
yeah. Or how to
harm reduction.
yeah, or how to reduce the
Effect
harmful
of
effects of biases.
You have to plan for that.
Yeah. So
From the design of the experiment.
yeah. So your methodology is kind of bottom up, right? You first learn the problems and then you try to
You have to imagine all that from the beginning. Like my colleagues in Israel, they are not like me. I have to take care of everything. They had the army hired them, and the army hired someone else to collect the data, and the data was collected all wrong. And my colleague says, I couldn't say anything because there was another company that signed a contract that to do this and that in a special way, and the special way was wrong for her. So she couldn't use the data she got from COVID patients.
yeah, but sometimes you have to have some general principles.
Yeah, you have to know from the start what kind of biases you're gonna face, and then you learn new ones. You learn new ones. You start with the boring with these ones, and then you learn about the other ones. Like I thought that I'm working in selecting patients. So, but I work inside the ward. So I try to collect data of when people are coming to the hospital. They always hate the collectors. They say, I'll never do that again because they are in pain. They go, well, I don't want to talk to you. I don't know what I have. I don't want to speak a sentence. Whereas when you're there, you have already been hospitalized. No one's talking to you. Nothing happens. You don't know if you're really good. And someone comes and talks to you. Oh yes, of course I can record. This is the right way to do it. But we did it right, but we didn't know we were doing it right. We were very lucky. Very, very lucky. Yeah.
I had some student, PhD students, they copy and collate small sentences in papers. And the plagiarism is growing. I mean,
We're going to discuss this problem on Friday, okay? Okay, but yes, yeah.
He's the only physician here.
You're only physician. Yeah. No.
He teaches at the
Did I not pay enough homage to these people?
Yes.
Yes.
It's there.
She's wonderful.
I think that he decoded the bacteria in 1 or 2 days.
Yeah, she was very quick. She was.
It was unbelievable.
It was before Italy. We had our sequence of genes in before Italy had.
Yes.
We had here in Brazil.
Yes.
Esther.
In one day and a half.
Yeah. And she immediately published, before she published the paper, she published the code.
Yeah.
And you know why? I've learned many things about COVID. I'm not an expert, but just curious. You know why COVID is so bad? Because there was this dogma in biology that you have DNA, then you have messenger RNA, and then you have protein. So this is how you take the DNA is transcribed into messenger RNA and it goes to the cytoplasm and you generate the protein. Okay, and then people found out this retrovirus, which is a retrovirus RNA that produces DNA, and that DNA reproduces the RNA virus. And COVID is a retrovirus, but normally retroviruses, they have 10,000, 12,000 bases, and COVID has 38,000. It's huge. It's huge and it's powerful.
And there's a capacity of transformation, I read.
And she detected that.
The capacity of
Yeah, because
reorganization
it has a lot,
is
it has
unbelievable.
more bases than has more way to avoid. Am I saying stupid things here?
No.
No.
I'm gonna.
It's not going to be the last time I. Sorry.
Because I'm gonna say Friday.
Okay. Fine.
The question is the plagiarism.
Plagiarism. What is plagiarism now?
Yeah. In the future, they are.
No, now there is no
make
future. Everything's happening now.
Sentences and or mind. You're gonna say, no, this is a plagiarism.
Yeah. And if you imitate Van Gogh's style, isn't that plagiarism? Because he developed the style. You just, okay, in his time there wasn't a person in a computer. You make a Van Gogh style picture of someone using the computer. Is that plagiarism or not? No, I think it is.
Thanks.
Another
Thank you.
question?
Yeah,
Yeah,
I have a question because in your talk you were talking about limiting biases and excluding biases.
No, never exclude. You mitigate.
And mitigating biases. And we are talking about automated systems. But we are like dealing with these problems in real life, real people, so people also have biases. So
Yeah, well, you have to. Well, that's the hardest kind of bias. Your own biases.
exactly. So
That's the harder kind of bias for you to learn how to deal with. Yes, but it's there.
So what I'm trying to ask you is that, okay, we train the systems, we try to get rid of biases, but like, what if we say that the systems are less biased than society? If you pay people...
I'll give you an example. When an algorithm was invented called the word-to-vec, it was an algorithm, neural learning, that maps a sentence into a vector. Okay? And then people try to do an intrinsic evaluation of what these vectors were. And suddenly they noticed that it could do some reasoning. Like it's an n-dimensional space, a large space, say 64 or 50 or I don't know. But you know that when you rotate, you multiply by a matrix, basically. So you could say a man is to a king as woman is to, and you take man, king, it's a rotation of this amount. And you take the vector of woman and you rotate the same amount and you get a vector and you look in your vocabulary, which one is closer to this one? And it's queen. Okay, so Italy is to Rome as Japan is to, and you go there and Tokyo. Wonderful, it knows genders, it knows geography. But then you do the famous case of there was a man is to a woman as a doctor is to a nurse. So it didn't relate a woman as a doctor as well, or as a surgeon or something like that. The woman was the nurse because the frequency in which in the text, there weren't biased texts in the sense that were macho text or whatever, but just by the frequency of co-occurrences between doctors and nurses and much greater than male doctors and female doctors, the system learned this implicit bias, societal bias. It was learned. So now when you do that, what we learn that we have to pay attention to the implicit biases. Because if you only accept it and you're going to reproduce the bias that's in the society represented by the probability of co-occurrences of words. So you cannot say, oh, I didn't know it wasn't there. It's your obligation to check. It's not a surprise that society has biases. It's not a surprise that your system learns that things. It's your responsibility to check that. That's what I'm saying. It's an ethical decision. Okay? Okay, thank you.